Thank you.
No, like you can.
Okay, hold on a sec. Let me show you this
trick.
trick. Okay, I'm gonna use the associative property. Yes. Okay, and I'm not gonna. You're right. I could do that, but that actually won't help me as much.
Well, it is possible.
It is possible, yes, because I can do k plus 1 times k plus 6. That doesn't help me as much as what I'm about to do helps.
What are you going to do?
I'm going to split this back up into k squared plus 5k, because that's my original statement, n squared plus 5n. And then what's left is 2k plus 6. Alright? Does this equal the statement before it?
Yes.
Remember the basic rule of math? The easy part of this is you're allowed to do anything you want to as long as it equals the statement
so
before
why
it.
did we ever do that?
Well, we didn't have k squared plus 5k anywhere in here until we...
Well, then why did we do the...
I'll show you in a sec. Okay?
No.
Now, we know
No.
that k squared plus 5k gives us an even number for our first term. Because we put 1 in and we got 6, right? Okay, so that starts out giving us an even number. Now, I can factor a 2 out of this and get k plus 3. So no matter what I put for k in here, it's going to get doubled, which will give me an even number, right?
Yeah.
Believe it or not, at this point, we're done with the proof. It's one of the hardest things about mathematical induction sometimes, is knowing when you're done. Since this worked for the first one, this will start off giving us an even number, right? Follow me closely here. Starts off giving an even number. To this even number of 6 on the first one, I am going to add an even number, because it's 2 times something.
But you just use numbers.
Hold on, an even and an even always gives me an even, right?
But you just
Right.
used numbers.
Slow down. I know I did, didn't I? So hold on a sec with me on this. I'm going to get very general. We know we start with an even number, right? We know we're adding to that an even number, which will give us an even number, right?
Why is that one an even number?
Because it's something doubled.
Oh.
Okay? So we know that this is going to give us an even number, which means our next term will be an even number, to which we will add another even number. And the result of that will be an even number, which will follow this formula, to which we will add another even number. Is there any way continuing to follow this process can get us an odd number?
No.
No, since we know this starts out even, and then we know we're adding something even to it, and remember, this is the same as n squared plus 5n. So once I add this, I'm going to get the same thing as if I put in 2. Once I add this again, I'm going to get the same thing here as if I put in 3. Once I add this again, I'll get the same thing in the first 2 terms as if I put in 4. And there's no way to keep adding an even to an even and ever get anything from an odd. So
it's all because of that middle addition sign.
Yeah.
I really wish I was in like Wonderland or somewhere, because I feel like math would not be necessary there.
You can argue how much. You can argue how much math is necessary for this. The more abstract math does have uses, but you don't get to it to use it all that often.
So
Yeah, this is pretty abstract.
plug in k plus 1 for n.
Yeah. So this is a little bit different than what we did over there. Over there, we algebraically proved that the k term plus k plus 1 equaled the k plus 1th term. Over here, we had to think. We had to say, okay, we know this starts with an even number because we plugged in 1. Are we always adding an even number? You can duplicate a process like this if you're asked to prove that an expression will always give you a multiple of 3 or a multiple of 5. Or if you want to solve the Riemann hypothesis of prime number. The Riemann, what Jesse's referring to, by the way, is the next great unproven theorem, worse than Fermat's, actually. There is no known way right now to predict prime numbers consistently. The thought is the first person who can figure out a way to predict prime numbers and keep it a secret from everyone else on the planet will have unbreakable codes. Unbreakable computer. Pardon?
They'll have $1 million.
They'll have $1 million from the Millennium Foundation. It's one of the 10 math problems for which there's currently $1 million prize
I'm so
from an
solve
academic
that.
organization. To give you an idea how the Riemann function starts to function,
Okay, wait, pause. What does this have to do with our homework tonight?
nothing direct, but Jesse brought it up, so blame him.
Wait,
But
Now I
you
have to
said
say it. Very, very quickly, guys. This doesn't take long. There
How
is
is
a
the
function in x, y, and I, the square root of -1.
This?
Okay, it has an imaginary z-axis. This function bounces up and down like the Loch Ness Monster through this incredibly
Plane.
weird space. Yet where it intersects the xy plane are thought to be able to be changed by another formula into a way to predict prime numbers. It is the least intuitive thing I've ever seen in my life.
But that could all be wrong because you said it's thought to.
It's got to be onto something because they've proven it works for like the first many prime numbers. But that doesn't prove that it works out into infinity. That's the rebuttal to what Johnny just said jokingly.
Even or not number.
It's neither. Infinity's really more of a direction
So
than anything
then
else.
it's like 0.
Well, no, for prime numbers, that's a little different. But
Right.
yeah, so they think this function in x, y, and I could be a predictor. It was thought up in the 18-something by a guy named Riemann, who proved a lot of stuff about calculus. And first one to prove it's true and find out a good way to manipulate it gets $1 million from the Millennium Foundation.
My goal in life.
There you go.
There's 10 times easier ways to make $1 million fun.
You're not wrong. This one's been stumping people for 150 years.
Yeah, but then I'll be famous.
You go.
In only the math world, though, so I don't know how much that's worth.
Yeah, Andrew Wiley, the guy who proved Fermat's last theorem, you know, I haven't seen him, like, judging American Idol lately
Yeah.
or anything like that.
Hey, you know what? I heard he's going to replace Ellen DeGeneres. How about that?
That would be beyond hilarious.
He would be like, who are you?
Yep.
Hey, I discovered something really awesome now. I don't really care. I just want American Idol 1.
Alright. Homework is on page 965, 4 through 28, every fourth. That's 7 of these. They start out simple.
They get complicated.
Great,
Can I go ask
Yeah.
Mr. Booth for $1.35?
Turn off the thing.